And we're just going to take a quick look at Parler text to speech. So I'm literally just cloning the repo now. It is, I don't know if you've seen it, but it's a text to speech AI that is trained to so I have this description here that you can describe the voice, like so it's got like a zero shot kind of voice adaptation ability where you can just describe the voice. It will then speak that text in that voice. So that's pretty cool. I think the AIs that take audio into account are a bit slow. Like there's certainly nothing like GPT-O, like, you know, they take just audio in, audio out. I think we're quite far from getting there, but if we can just get really good at describing the text coming out of an LLM, you can have a pretty nice.
Will you surprise me and speak in whatever voice you wish?
So that's pretty good. Yeah. So you could build a pretty nice chat-based system or a system that will help you read to your kids as they help them learn to read. There's a lot of like good accessibility gains to be had by having good text to speech. So we're just going over to files here and just seeing how they've done it. So it's a large language model, like a big like sub 1 billion parameters, but I think it was maybe 600 or 700 million. So it's going to support running on the GPU. Got some examples. We'll just try to get it running locally. So we'll just open it up, have a look. Oh, oops, I landed in the wrong place. Up level. Let's have a look. So it would be nice to just be able to get it running really, and then we could run something like this as an API for people. It's actually still pretty expensive to generate text by API. So let's see how easy it is to get running. Or you just use it as an API on Hugging Face. Oops. It's like a bit of an old Python version. Oh, it's weird. It's still old. Weird. That's strange. I guess we can just try the old Python version for now. I'll figure out what's up with my env later. Kind of concerning I wasn't giving me the right Python version, but let's see. Oh, it's a weird requirements file just for GitHub. So it's going to have to run the model from somewhere. So yeah, okay. So it's automatically going to pull this model from Hugging Face, which is fine. But yeah, we just maybe we should get on top of that and like kick that download off as soon as we can. Uh, let's see. Just checking out. So download all the NVIDIA stuff. Uh, the models downloaded. We can see like the tokenizer. We've got some extra tokens, and then yeah, this is how it's tokenized. So I don't know if this is different than like a normal tokenizer, but you can imagine for speech, you might want to tokenize by kind of like a more kind of auditory, like a phoneme, like a part of language that just makes a sound. But you can see that's not really what they've done here. It's like full words most of the time. Looks like a normal LLM with things like est, ing, that kind of thing. There with endings and such. So it's worth noting. It kind of reminds me of what the OpenAI team demoed, where they were just changing their prompts, and then the GPT-O was kind of changing the way that it was speaking. So it's all speculative, but they may have trained on some kind of a detailed description similar to this, where they generate really a detailed description in their training data of how the output audio should sound like. And so that kind of gives you the ability to describe in words what you want the resulting audio to sound like. And they'll probably, now that we can voice text, you can back generate that into audio as well. And then you can then retrain on the audio instructions with the goal of getting audio. So that's like some speculation into what they may have done. Because this is a radio code, it's a bit interesting. Like you can see they just return sample rate and audio. They effectively tokenize the text and description. Looks like they've got some pre-processing on the text, but not on the description of the voice. Yeah, so you don't need to do that on the voice. You're not going to describe the voice using like weird numbers and symbols and stuff. You don't need to do this. Seed 42. And then, yeah, it's pretty much sending it to the device here, generating, and then bringing it back. You'd want to then like encode this audio somehow. If you're running this in production, like some kind of create some kind of MP4 file. I do run a product called text generator, and that also generates text. This is open source, so this is kind of a good comparison. It also runs on a radio. So how does it work again? I forget. Let's have a look. Text to speech. That's just rendering the actual page where you launch text to speech. So inside this inference server, it will have that. It'll be the actual place you're requesting the API. So the current, it is like an older text to speech system. Actually considering changing it out for Parler. See how it goes. Just got a cache in here. Audio server. I think I dissolved all this stuff so that it's all done in here as well now. Audio model. Oh, that's Whisper. So you can also do speech to text using text generator as well. eventually thinking about downloading the audio from any linked YouTube videos. Yeah, so you can just have to give it links, ask it about YouTube videos. This is all just with Whisper, so I'm kind of in the wrong place in the code base entirely. Yeah, the vocoder, that's part of this natural speech pipeline. So I think this is fairly similar, yeah. So it's returning the natural speech data and I think that's the rate, the bit rate. So I don't actually remember I convert this to a web, which is maybe not the best format. I need to do some testing on what the best format is. And I just return the web file here. I wonder if I really shouldn't use web. It might have some kind of issues with the actual audio quality. So I should do something much better. Got a few speaker embeddings here. So actually using the sound file library to write an audio file. Yeah. That's actually what you'd want to do if you would want to get the file as an actual audio file. Radio kind of handles it for you, but let's go back to have a look at Parler. Did I just destroy the window? I think I did. So I'll try. That's bad. I wonder if that gonna ruin my being able to run this. This is probably gonna take another really long time. Yeah. So we finished setting it up. Let's try. Oh, this is Hugging Face Spaces. I've never seen it before. Oh, I'll just comment that. Looks like it's that new kind of zero GPU thing. Maybe those are automatically installed into if you've got a Hugging Face Space. Would be nice to have like a little have like an API for this. I guess that's what this is. Like kind of something like that. Just like a really plain just call it and save a file type thing. Like a benchmark, maybe like how long is this going to take? Um, Was it the 0, 0? This is the first example. Without it. NV link and data version. Lib NV jet. That's not good. Let's see, anything like that before. Okay. That might mean that I have to just fully do, like, I should have really sorted out my Python version. Which version? Oh, I, oh, you didn't need to do that, but do that. Oh, that's not the. Uh, hmm. I don't know if that installs the Cuda versions. Maybe I need just the Cuda versions of Torch. Roxy, that's not going to work. Roxy is like an AMD thing. Um, yeah, need to make sure. Yeah, what are our version? 12. Yeah, it should just be done. We could, yeah, it should just work. I don't know why it did went to Roxy. I just, hmm. I think I'm just going to try and install the right Python version and redo it. Which is going to take a while. Like, you can't even import Torch here. You got it. Yeah. So just ruined the whole environment. It's pretty much ruined. Um, let's see what's going on here. I think I might have got some kind of incorrect path or something. Oh, that's it. Maybe some kind of, yeah, I just need to reload. Right, that's to, I guess, sort your environment out first. Once again, and There we go. And we've got a long ways ahead of us. Hopefully, a lot of those packages will be cached by Pip, but still. Oh, it's done. Oh no, same problem. Okay. Let goose pass. I think that's kind of a similar, like, same problem where we kind of want torch because of some like, reason. We're on Cuda 12. See what's installed. Same. Hmm. Hmm. I think this is probably one of those times when you should just import torch with this plus. No, it's me. I should remember this. Only library path. That's why I messed my computer up. Jesus. Oh gosh. I'll take my own advice. Seems to work for me. Yeah, so it's pointed to CUDA 12 and CUDA 11.4, which that's like, yeah, it does look a bit messed up. So let's try that. So let's check that's there actually. Yeah, for 11.7. Oh, wow. Okay. It's not even. Oh, yeah, I'll have to look into that one and tell you what it is. I have no idea. I've been signatured myself. That looks like me. Classic, classic. Link to my link to my startup. Looks like at least I've helped some people. Yeah, it's good to always try updating Cuda. So it hasn't started yet. Guessing it's just loading this. What do you call it? Just loading from the GPU probably. So, normally on like a bit of a beefier computer than this, which is then a combination of arguments. Transformer utils. It looks like that's some transformers. And I wonder like what it's actually is. Like let's try and install this. Come here. Yes, right. So this will be built. Transformers. It's got like below some version. Probably the highest, yeah. Yeah, so that's it. It's weird. This is less than, but that's equal to. So we can just try installing a different version. But we should also like understand, of course. And so it's like a different, so obviously changed a lot since we changed the version of Transformers. Take a while to load again. It's not really clear. Some kind of deprecation warning. Logging error. Yeah, I wonder what the max length is of like, I have to test this model out and see what it's capable of. Like, what's the biggest, longest bit of audio it can generate. Not clear if that is, oh, is there, I wonder if it's actually running on somewhere. Yeah, it really prints, but no. And so that's like stopping criteria is something that stops the generation, and you can pass stopping criteria when you generate text. And this EOS, like the end of string token, sort of like stop when you reach this token, just kind of terminates the generation. Example 2 out of 4. So still caching examples. It's kind of weird that it does that like easily. It's taking a long time. Using all of the GPU now, which is cool. I just wanted to experiment with it, really. I didn't really care too much about rendering out all these examples. But it's interesting to have a listen. We need to find some kind of a way to we need to save this audio. I don't think it's got here yet. It's got to do another generation after this. And hopefully that'll like actually cache it somewhere and not just take a really long time to start every time. We could use this little right lab thing we've got here. Basically like that. And save that as a file that's bytes. Just to we'd actually have to import this. I can install this. Send file. I guess I'm going to be starting now, doing what we said. Seems like really, really slow. So yeah, that if we've already rendered these, we should be able to listen.
Remember, this is only the first iteration of the model. To improve the prosody and naturalness of the speech further, we're scaling up the amount of training data by a factor of 5 times. Remember that
Sounds great. It's really good. I don't know if I'm sharing audio. That's okay. Let's just listen. You might be able to hear them.
It's the best time of my life, Bardley, she said happily.
Sounds great.
Montrose also, after having experienced still more variety of good and bad fortune, threw down his arms and retired out of the kingdom. Montrose also, after having experienced still more variety of good and bad fortune, threw down his arms and
Almost like-
retired out of the kingdom.
It's almost like 11 Labs level, like it's so good. To see if it can be very informal. It's nice to go fast pace. You know, it's going to save you a lot of time and money, like having it fast. Maybe actual audio spoken fast. Then you won't generate as much. Um, hmm. Interesting that you should kind of take note of the descriptions. Like this is this type of length and description, like the actual text. That's kind of how you would phrase your description of someone. Like it's quite a verbose way. Okay, that's 2 seconds real quick.
Hey, what's up? What's cracking?
Cool. It didn't say how long that took, but that felt pretty quick. Here we go. Out of 20 seconds. I don't know if that or that took 20 seconds last time. That takes a long time compared to text generator. Yeah, that's about 20 seconds.
Hey, what's up? What's cracking with you, Chapel?
Yeah, so you have to use like augmentation, like capital A dot capital I dot, and you might have more luck having it. But you have to be good at like audio prompt engineering, like describe how it should say things instead of just the text. This might be a little bit clearer. Instead of saying I think I have to just want to say AI.
Hey, what's up? What's cracking? I'm into a hey, Chapel.
Hey, still pretty good, but I might be able to just augment my way, getting it to say stuff like that. It's good, but 20 seconds is a little bit slow, so I would need to we need to do something about that. So, but it's really good. It sounds great. So what you can do, here, you can get a bit of develop and probably do it. It is converted into floats. Autocast. That's like not ideal, but yeah, that's something we could do. That's like that's pretty good. And you can also do torch node-grad. Yeah, but you don't need node-grad. If you can, you can use inference mode, which is even faster than node-grad. Really, we should like make this model.to device. Yeah, we should have done that. And we should do, did we not do that? Yeah, we've done that. But before we send it to the device, We can half the parameters. And yeah, and so to eval as well. That converts it to 16. Is that how you do it? Yeah. What do you say? Just cancel all these examples if it's going to try and load them all. It'll probably like not work because of some error. Yeah, VF16 is not going to do it. As time, how do you cast again too? Oh, there we go, too, yeah. That looks right. Well, those are the kind of first order of business converted into a lower precision. Use torch inference mode. Autocast is like defensive, like if you're about to do an unsupported operation, you can catch you there and then use the correct one by down scaling one of the parameters, but really it should be, here we go. Something, yeah, it didn't work. Yeah, you didn't need to do that. So then there's like torch.compile, which this is a plugin face model. I think you can still torch compile it. Yeah, you can try that. Oh, and so now we're getting a different error, which is always exciting. Probability contains either inf, nan, or. And normally this happens when the network just is not going to support this type of quantization. Like you'll have to be more careful to be able to get away with lower precision, like maybe only some layers in the network. Maybe it's just dependent on the data. Maybe you can just get away with instead doing only the torch compile thing.